This question is asked in GATE 2014. Question is very big, so I am not writing it. If you want to see the actual question, you please Google it out. You can find it somewhere. It is asked in GATE 2014. So what I will try to do is I will explain you the exactly what they have asked in question, and then we shall solve it. So they are given that there is a 5-stage pipeline like this: 1, 2, 3, 4, 5 stages pipeline, and each stage is going to take this much time. So instruction fetch is 1 nanosecond, instruction decode and register fetch is 2.2 nanosecond, execute is 2 nanoseconds, memory is 1 nanosecond, and write back is 0.75 nanoseconds. So each stage is going to take the times respectively as shown, and now let's call it pipeline P. Now what they did is, instead of see, one problem with this particular pipeline is the time period for this pipeline has to be set to the maximum duration possible. So what is the maximum duration given in this? The maximum duration given is 2.2 nanoseconds, right? And accordingly the frequency of the clock has to be set to 1.2.2 nanoseconds. Now we know that the frequency of the clock also indicates the number of clocks per second, which means the number of instructions per second, right? So somehow in a pipeline processor, the number of clocks per second will be equal to number of instructions per second if everything goes on well, which means if there are no stall cycles, right? So in order to increase the performance of this pipeline, they are trying to decrease the time period of the clock, by which they are trying to increase the frequency of the clock. As you increase the frequency of the clock, if there are no stall cycles, you are supposed to get a better performance, because as you increase the number of clocks per second, you will be executing more instructions per second, right? So they tried to do that. So what is that they are trying to do is, they wanted to improve the frequency of the clock, and so they wanted to decrease the time period of the clock. And if they have to decrease the time period, they have to decrease this number, right? So for that reason they are splitting some stages into multiple stages. So they have developed the next pipeline, let's call it Q. Okay, so the pipeline Q is containing instruction fetch as it is, and the time taken for instruction fetch is 1 nanosecond. And coming to this particular stage, they have divided into 3 stages. One is instruction decode, second one is fetch the first operand, and fetch the second operand. Operand fetch is divided into 2, and for each one of them they have distributed the time equally, which means 2.2 by 3 nanoseconds, 2.3 by 3, which means this entire stage is divided equally into 3 stages, right? And then this stage they divide into 2 stages. One is execute 1 and the other one is execute 2, and each stage is now given time 1 nanosecond, and this one is left as it is, which means memory 1 nanosecond, and write back 0.75 nanosecond. So the 5-stage pipeline is now divided into probably 8-stage pipeline. 1, 2, 3, 4, 5, 6, 7, 8. Yes, 8-stage pipeline. Now let's call it as Q, right? What is the advantage of this? As we increase the number of stages, time taken for each stage will be less, and so the frequency of the clock can be high. Therefore, in this case, the frequency of the clock depends on what is the maximum time required by any stage. So the maximum time required by any stage in this one is 1 nanosecond only, because 2.2 by 3 is close to 0.71, and 1 nanosecond 0.71, 1 nanosecond 0.75. Therefore 1 is the highest. So the frequency of the clock has been increased, and if everything goes on well, the pipeline Q is supposed to give you better performance compared to pipeline P, in case if there are no conditional branches or anything like that. Okay, and now they are saying that if we have to execute a program, they are saying that we have a program. If we have to execute a program, Then the program is in such a way that 20% of the instructions in the program are conditional branches and 80% of the instructions in the program are normal instructions. And coming to these conditional branches, we will be knowing the target address in case of the pipeline P after this execution phase, and in case of pipeline Q after this execution 2 phase, right? Then they are asking us what is the time taken, what is the ratio of time taken in pipeline P divided by what is the ratio of time taken in pipeline Q, right? So let's see how much time will it take in the pipeline P, time taken to execute the program in pipeline P. So it depends on how many stall cycles are there and all this. So if you see this, 20% of the instructions are branch instructions, and their target instruction, their target address will be found out after this execution phase in case of pipeline P. Therefore, if you try to execute those type of branch instructions, we will be able to execute or the number of clocks required for each of such instructions will be 3. 1, 2, 3, isn't it? So if you want to see this, we are having 5-stage pipeline like this. And now we cannot, they have given clearly in the question that if you are executing a branch instruction, then we cannot start the next instruction until we know the target address, and they are saying that in case of pipeline P, the target address will be known after this particular execution stage, right? Therefore, in case of branch instructions, we will be getting one instruction every 3 clocks, which means clocks per instruction in case of branch instruction. In case of this pipeline P is 3. Got it? Therefore, for 20% of the instructions, which means for 0.2, the number of clocks required is 3, and in this case each clock time is 2.2, isn't it? In pipeline 1, each clock cycle is 2.2. And for the remaining instructions, which means for the 80% of the instructions, 1 clock is required for every instruction, and as usual the time period of the clock is 2.2 nanoseconds. Got it? And now coming to the pipeline Q, we have to analyze it the same way. So in this case, we can know about the target instruction, target branch instruction, target address only after EX2, right? Therefore, how many clocks are required for each such instruction is 1, 2, 3, 4, 5, 6. Are you getting this? Therefore, in this case 0.2, which means 20% of the instructions are going to take 6 clocks per instruction, because target branch address will be known only after EX2, that is given in the question. It is better you read the question to get it, to understand it clearly. If you are not understanding my explanation, you read it, okay? And then it is given as 1 nanosecond, because in the second one the clock time is 1 nanoseconds, right? And then for the remaining 0.8 into 1, it is 1 nanosecond, right? So you have to compute these two, and then they are asking what is the ratio between TP by TQ, something like this, or okay. So which means if you are having this pipeline, for the better performance you are going for this. It is supposed to give you better performance. See, assume one thing, assume that there are no branch instructions at all, there are no stalls required, then which one do you think will give you better performance? Obviously the pipeline Q. The reason is for every 1 nanosecond it is giving us 1 instruction, but here for every 2.2 nanoseconds we are getting out 1 instruction. Therefore pipeline Q is supposed to give you better performance, but because of these many stages the penalty will increase, right? So in case there are branch instructions, so you can find out TP by TQ and see how much improvement did you get in the performance. You please calculate it and you get the answer. I'm not sure what the answer is. We just continue carry out these calculations, okay?
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkey's ranking is 400. If you are happy to get into IIT Roorkey, then getting into universities better than IIT Roorkey is easier compared to getting into IIT Roorkey. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities, but whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is, we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.